Hi, I'm Tom Williams from Colorado School of Mines. I'm sorry I can't be presenting live. I'm currently on an airplane. Today, I'm going to be talking, like a lot of people probably, about the elephant in the room that is large language models like ChatGPT and their role in robotics. The release of ChatGPT led to some pretty incendiary headlines. And what I want to ask today is what uses do large pre-trained models like GPT actually have in social robotics? And what are the risks that should be mitigated in order to use these types of models effectively? Everything I'll be saying today is the result of extensive discussions amongst myself and Drs. Cynthia Matuzik, Ross Mead, and Nick DePalma, and it's described in more detail in a paper that we've co-authored that should be forthcoming. First, I want to talk about why there is reason to be skeptical about the use of large language models in robotics. The first risk that people are probably pretty aware of is the fact that large language models are designed to confidently bullshit. And I mean this in the sense of the sort of formal linguistic sense of bullshitting that is attempting to persuade a listener of some disposition or state of affairs while not caring about the veracity of what is said. ChatGPT and large pre-trained language models in general all are designed to generate text confidently that seems like something that a human would say without caring about whether or not it's true. There's no way for these types of models to care about what is true. They're just generating text for the sake of generating text because they've been rewarded to do so during training. The second problem is that large language models have been shown to encode racist and gendered stereotypes. This is also not terribly surprising because these types of models are trained on text from the internet, which itself is full of racist and gendered stereotypes, and as such, it's not surprising that these types of models are replicating these types of biases that we see in humans. This gets at a slightly deeper concern, though. Large language models like GPT, we could also say, are trained to center whiteness. They center the perspectives of a default white and often white male perspective, in part based off of the data they're trained on. They use the syntax and word choice and other linguistic cues that are associated with standardized American English. Again, sort of centering whiteness and specifically white male Americanness as central and objective and confidently true in a way that excludes and reinforces the marginalization of women and people of color. The use of large language models may also conflict with equitable design practices. In the human robot interaction community, we have done a lot of work on studying the importance of working with communities to co-design the language that robots use. Current approach that we are seeing with GPT tends to be, let's forget everything we know from a scientific perspective about what is successful in communication and what particular communities want, and instead, let's just look at whatever is coming out of these large language models. And finally, the largest problem, perhaps for robotics in particular, is that much human-robot interaction dialogue needs to be grounded. It needs to connect to specific objects that are in the specific environment in which a robot is embedded. But large language models don't yet have an understanding or knowledge of the specific situated context into which robots are deployed. Now, this isn't necessarily an argument purely against the use of large language models, but it says that because robots need rich systems for taking information about the world around them, understanding the structure, and encoding it in some way, that an effective use of large language models is going to need to leverage that existing structure and those existing sources of situated knowledge rather than starting from scratch and trying to do everything. A lot of these concerns aren't new, and people have been raising concerns about these types of large language models for a number of years. I've been talking about these sorts of things in talks since pre-pandemic. Ehud Reiter, one of the founders of the field of natural language generation, has put it like this. Authors of deep learning-based natural language generation papers are fixated on fluency, but regard factual accuracy as unimportant. This is a bizarre perspective because one thing that 30 years of natural language generation research has taught me is that readers of NLG texts care hugely about accuracy, and indeed prefer accurate but poorly written texts over inaccurate but fluent texts. And this is particularly problematic for us in human-robot interaction, where every domain has the potential to be safety critical, not only because there may be potential for physical harm, but also because there's potential for social, emotional, moral, psychological harm, especially when dealing with young kids and older adults. This is particularly problematic in robotics as well, because robots have a lot of potential, not just to influence people and persuade people, but more specifically to exert moral influence over people. That is, in some of our previous experimental work from our lab, we've shown how robots can have subtle influence over the systems of moral norms that people use to decide what is right and wrong. Okay, so at this point, many of you and maybe some of the organizers might say, Tom, I think you're maybe being a little bit too critical. There are ways to use large language models that minimize these risks. And yes, I agree. So now that I've talked about some of the risks that we're seeing, here are some of the opportunities. So our key insight is that the types of risks I have talked about present themselves when researchers and developers try to use large language models to entirely determine the content of a robot's communication. Speech from a human comes in, goes into large language model formulates a response, speech goes out to human. That's where we run into these problems. But there are a lot of ways that we can really use large language models in our robot architectures that don't run into these problems at all. A great example, and a way that our lab is already using large language models, is just for parsing. In our lab, for example, if we want to get a new student up and working with the robot, and they want the robot to understand language, the first thing they need to do is get the type of language they want the robot to understand, working with the robot's parser, which takes in language and turns it into a structured logical representation. For example, taking something like put the box on that large table in the kitchen, turning that into something like this is a command from the speaker to yourself, saying to put X on Y, where X is a box, Y is large, Y is a table, Z is a kitchen, and Y is in Z. Currently, the way we would handle new utterances is by editing a 500-line file of painstakingly written lambda calculus rules that describe in formal terms how the syntax and semantics of an utterance translate into logic. GPT solves this type of problem with a prompt containing only about a half a dozen examples and gets things right most of the time. This is a huge win for us because we are not parsing researchers. We do not really care about parsing. We just want something approximating a semantic parser to be working so that we can focus on the things we care about. Most human-robot interaction researchers are also in this boat. This is an area where there is very little risk of when going from language to this very closely related logical representation, there's very little risk of inaccurate or immoral content making its way into the output. And moreover, what we are doing here is using LLMs in a way that is inherently connected to the grounded sources of knowledge that the robot has and making that interface work. Second, another example is text realization. This is the problem of going from a structured logical representation to something where the robot wants to say to actual text. Again, currently we do this by modifying a 1,000-line file of horrible Java code that's hard coding all these syntactic construction rules. And again, GPT solves this problem with only about a half dozen examples. And while this is a form of natural language generation, and we need to be careful, the specific way that we're doing natural language generation, where the robot already has an intent it's trying to communicate, it's already decided what properties it wants to use, it's already decided most of what it wants to actually say, and just taking that and translating it into something that is fluent. This does have some problems. For example, this is using standardized American English. You could say that this particular approach with the particular prompt we're using is centering of whiteness. But using ChatGPT, it's very easy to even mitigate that concern. So to summarize, the potential for generating false and malicious or immoral language under these types of uses, where we are using GPT not to simulate all of language, but rather to help solve particular places in this grounded language pipeline, is pretty minimal and shouldn't interfere with our equitable design practices. Is this an intellectually satisfying approach to solving those types of problems? No. But it might not need to be. The field of human-robot interaction already uses some not so satisfying, from an engineering perspective, solutions at times when we just need to get things done. A classic example being Wizard of Oz. When we're running experiments, we frequently cheat by having somebody teleoperate the robot for some capability that isn't really ready for prime time, just so that we can get things done and study the things we want to study. Because in robotics, our systems are AI complete, and moreover, they're AI and psychology and linguistics and language complete, meaning in order to really solve these problems, you need to have all the information from all of those fields. And one research team can't do everything, and so we are going to have to be smart about which problems we're actually making our students solve and which ones we leave to systems like GPT. So to formalize and extend this Wizard of Oz metaphor, we are saying that wizards in Wizard of Oz replace a process in our architecture with a hidden human to get an experiment to run when it isn't worth automating the process yet, as it's too difficult for us to currently computationalize, especially when that computationalization is not our immediate research goal. We call the use of these large language models, in the way I've been talking about, scarecrows, again, to extend the Wizard of Oz metaphor. That is, replacing a process with a brainless large language model just to get an architecture running when it isn't worth using a formally verifiable or understandable method for that process yet, as it's too difficult for us to currently computationalize in that way, especially when that computationalization is not our immediate research goal. Of course, this isn't an excuse to be lazy, and we've been thinking about how we can use scarecrows in an appropriate and responsible way. We've argued that when using a scarecrow, we need to report out to the community or in our code packages the specific model we're using and all of the parameterization minutiae that need to be reported to. We need to report why we're using scarecrows as opposed to other less complex baselines. There's been a few pieces of research over the past 5 years showing that linear regression tends to work better than some of these big deep learning systems when appropriately labeled data is actually used. It could be the case that for some of the things we're considering using large language models for, a simpler solution might work just as well. We should report how our use of large language models mitigates the key ethical concerns surrounding large language models and what concerns remain. And finally, the path forward. If we're using these types of models as true scarecrows, just as brainless replacements for things that we don't want to deal with, we want to talk about what the path to their replacement might be, what type of work we might want to or need to do in the future in order to, or what type of other systems we might need in order to remove those scarecrows at some point. On the other hand, if we think that these large language models are actually an appropriate and optimal and ideal state-of-the-art solution that is the current best we can do, both in terms of performance and other types of factors we might care about in HRI, then we should talk about how the use of the large language model in that way in our architecture needs to be evaluated in separate work. So the main takeaways here are that large language models have tremendous risks, and simply putting ChatGPT on a robot and calling it a day is a recipe for disaster. But large language models like GPT have great promise for HRI when used carefully and selectively, and key considerations must thus be made when using and reporting the use of large language models in human-robot interaction. So thanks to Cynthia, Ross, and Nick for the great discussion and helping sort of co-write these ideas. Thanks for the folks who are funding me to think about these types of things, and thank you for having me virtually and asynchronously.